Alright, so on problem 29 here, we are using waist size to predict body fat percentage. And then we got our residual plot and our histogram of our residuals and our normal probability plot. So we got to test a hypothesis, and then if we find a significant, if we find that there is a linear relationship, then we have to do a confidence interval. So let's get to work on this. So our parameter here, big B, is that there is a linear relationship between body fat percentage and waist size, and I'm just going to put in inches, okay? And our hypotheses, the null is that big B is 0, the alternative is that big B does not equal 0. The assumptions, if we look at the scatter plot is straight enough. The residual plot shows no pattern. Okay. The histogram of the residuals is roughly unimodal and symmetric. And we can make a comment about our normal probability plot, but and then it's each person's is independent in regards to body fat percentage and waist size. Name the test. It's a Lin regression t-test. To test statistics, everything I need is right on this bottom row, because that is going to be where our slope is. And then our n size is 20 and our degrees of freedom is 18. So n is 20, degrees of freedom is 18, b sub 1 is 2.22152. Standard error is going to be 0.2728. So I'm going to write that least squares regression line. So predicted body fat percentage equals the y-intercept, which is negative 62.5573, plus 2.22152 times waist size in inches. Okay. Obtain P. T is going to equal B sub 1 minus B sub 0 over the standard error. And our T value is like 8.14, which is right here. Okay. So it's 8.14. So this is a two-tail test. So we're going to have T is negative 8.14, T is positive 8.14, P is going to be less than 0.001. Make a decision. So since P is less than 0.0001, eject at the 0.05 level. And our conclusion, since P is less than 0.0001, there is strong evidence of a linear relationship between body fat percentage and waist size in inches. Okay. R squared here is 78.7% right there. So R squared equals 78.7%. So 78.7% of the variation in body fat percentage is explained by the variation in waist size and then we got to figure out our R value. So we're going to do the square root of 0.787. Let's do that up. Square root 0.787 and we get 0.89. Okay, so R is 0.89. And it's positive because the scatter plot goes up as waist size increases, body fat percentage increases, so we're going to leave that. So there is a strong positive linear relationship between body fat percentage and waist size in inches. Okay, so that's good. So let's do the confidence interval now. So since we did a two-tailed test, we'll do a 95% confidence interval. So our confidence interval will equal b sub 1, 2.22152, plus or minus t. So this is a 95% confidence interval. So if we do a 95%, that's 0.025, 0.975. And you guys may be saying, well, why do you draw it every time? I just like the visual representation. It helps me rather than trying to do it out in my head. Degrees of freedom here is 18. So we got 2.1, right? Okay, so 2.1 times the standard error, and the standard error here is 0.2728. And so we're going to do 2.1 times 0.2728. Put that up for you. And you get, what, 0.573. Okay, so we'll do 0.573. So that's our margin of error. So let's see, 2.22152 minus 0.573 is 1.65, and we change the minus to plus, and we get 2.79. So we are 95% confident that as waist size increases by 1 inch, body fat percentage will increase between 1.65% and 2.79%. So for every inch that you put on your waist, we're 95% confident that as every inch you put on your waist, your body fat percentage will go up between 1.65 and 2.79%.